And once again, everybody, welcome to the Morrison Planetarium. Feel free to sit in any row that your heart calls to you. Just make sure to move towards as close to the center as possible, as comfortably as you feel as well. We do anticipate a large crowd to join us for the last planetarium show of the day. We do have about 3 or 4 minutes before we can get the show started. And this is a good time just to remind everybody that this show is 30 minutes long. This is going to take us to the closing of the museum. The show is 30 minutes long. The museum closes at 5 o'clock. So just make sure this is where you want to be for the last 30 minutes at the museum today. I think it's a good place to be. Alrighty, everybody. It looks like I just got the okay to start our 4:30 planetarium show. Once again, everybody, welcome to the Morrison Planetarium. Since I got the okay, I want to be putting away our space trivia questions away for just the meantime because we're going to be heading into the unknown. Ooh. And welcome again, everybody. I just want to introduce myself real quick. My name is Christian. I'm going to be your planetarium presenter. Just a heads up, I'm not a big scary voice coming out of the walls. I'm actually a person standing right behind you up at the pilot's booth. Hey, how's it going, everybody? But don't hurt your necks. Look forward into the dome before you. That's where the whole show is going to be. Everything that you see in purple is going to be one massive screen, thanks to the help of 6 different projectors hiding throughout this planetarium dome, which is going to give us that very immersive experience. And just a heads up, y'all, everything that you're about to see on our screen is backed by scientific data. We like to use peer review, critique, and we also like to use the latest in science visualization software to give you a very immersive experience. So again, one of my favorite things about the Morrison Planetarium is that everything that you see is backed by science. And just to let you know, folks, the show that we're about to do right now is different from all the other shows that we've done here in the Morrison Planetarium. This show is called Tour of the Universe. This is a completely live show, so for the next 30 minutes or so, you're going to be hearing my voice. Essentially, we're going to be starting off pretty close from Earth, and we're going to be zooming all the way out to the very edge of the known universe. So hopefully by the end of the show, you won't be having an existential crisis of where we are in the universe, but hey, you never know. Just prepare yourself. And before we get started, I got to go over some quick house rules just so that everybody in the audience is on the same page. We have a great experience inside the Morrison Planetarium. First off, there is no food or drinks allowed inside, so if you manage to bring any snacks or beverages, make sure those are tucked away till the very end of the show. We want to keep this place nice and clean. Also, that includes no feetsies on the seatsies. Again, we want to keep the seats nice and clean for all the folks who are going to be coming and join us in the future. So we highly appreciate that. The second one is the biggest one. Please, folks, wear your mask while you're inside the Morrison Planetarium. We've got about 140 people in under our dome right now. So I can't stress that enough. I highly appreciate your cooperation. Thank you so much, y'all. And folks, if you happen to have any 21st century gadgets like cell phones, smartwatches, laptops, beepers, if you still got them, now's the perfect time to turn them off, deactivate them, put them away for the next 30 minutes or so, just because having a really bright white light in a very dark dome like this planetarium can be distracting for the folks sitting behind you. And folks, you're more than welcome to exit at any moment during the show. All we ask is that if you do leave, please make your way up the stairs. That's where the exits are going to be located before, during, and after the show. So when in doubt, always make your way up the stairs, not down them. It's very dangerous to walk down the stairs in the dark. You can easily trip and fall in the dark. Trust me, I know. I have bruises. They really hurt. And folks, this show is quite immersive thanks to the help of those 6 projectors. If at any moment during the show it becomes too overwhelming, you become motion sensitive, there's a really quick and easy solution for you. All you got to do is close your eyes, take a few big deep breaths. Your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling through space, at least not more than the usual. But otherwise, it looks like we're good to go. So let's begin our tour of the universe, y'all. Wowzers. Alrighty. So we're going to be starting off again pretty close to home. We're looking at something that looks not too familiar. What we're looking at is known as the International Space Station, or what we also like to call it, or shorten it as the ISS. Essentially, this is a science laboratory orbiting around low orbit around planet Earth. And what's amazing is that this is a collaboration between many nations on planet Earth to pretty much figure out what exactly happens to things in space. So they conduct all sorts of science experiments up here at the International Space Station. For example, how does a plant behave in a low orbit with little gravity? Do they grow longer? Do they grow shorter? How does an open flame work in space? These are all the different types of science experiments that they conduct up here. Now, one of my favorite things about the International Space Station is that this thing is going incredibly fast, folks. It's going a whopping 17,000 miles per hour around the Earth, where it orbits once every 90 minutes, where it also experiences 16 sunsets and 16 sunrises a day. Whew, that's romantic. And you're probably going to notice, folks, all throughout this whole show, I do have a bit of a sense of humor, so I have jokes all throughout. So just a heads up, I've got plenty of cheesy jokes. But folks, Way up here in this in space, looking down at the International Space Station and seeing the Earth right below us, it looks like the International Space Station is incredibly far away, but it's actually not that far away from the surface of the Earth. It's only 225 miles above the surface of the Earth. 225 miles, that's like San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend. And folks, the International Space Station is the biggest thing that we put into orbit so far. It extends about the size of a football field, and it keeps getting bigger every year because we keep adding new compartments to it. But traveling into space is quite expensive. This is as far as we put humans into space nowadays because, again, traveling into space gets quite costly. You got to account for all the rocket fuel to get you off the planet, not to mention you got to bring all the food, water, and all the air you're going to be breathing, so the bill starts to add up quite quickly. But we're going to start to slowly pull away from the International Space Station because, again, this is Tour of the Universe. We need to make our trek all the way to the very edge of the known universe. So we're going to slowly see the International Space Station slowly disappear compared to our planet. And it should disappear into a nice little orange line. There it is. So we can still keep track of the International Space Station as we continue to zoom out. And now, folks, we are looking down at our big, beautiful homeworld, planet Earth. And just to let you know, we're using a fun software here called OpenSpace. This is an open source program that you can download at home, but I highly recommend if you do download this, you should definitely have a high processing computer, either a gaming computer or definitely a desktop. This program does pull lots of information. In fact, the weather clouds that you're seeing right now, these are almost real-time data. This is what the weather was looking like around noon yesterday. So it does pull from geo-synced satellites to give you the weather, a really close representation of what's happening pretty much in the present, pretty close to the present as of yesterday. But again, we're going to slowly leave our planet Earth. And now we're going to be making our way over to our nearest natural neighbor to us in space, the moon. Now, how many folks in this planetarium have been to the moon before? Say yo. I did hear a yo in the distance, and if you did say yes, we have a couple of scientists that want to ask you, what are you doing in this planetarium show? But in all seriousness, folks, we humans have been to the moon before. This was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon and even play golf up here as well. Now, this was the only brief presence of humans on another body in the solar system, but that should be changing in the very near future because NASA has new plans to send humans back to the moon thanks to a new NASA mission called Artemis, which is going to be bringing the first woman to the moon, but also they have plans to be setting up a lunar base here because eventually we humans want to continue our exploration of our solar system. So the moon is a perfect practice space or place to figure out how exactly humans would live on another celestial body here in the solar system. So pretty close to home. And by pretty close to home, I mean the moon is about 240,000 miles away from the Earth. So if you're in a rocket ship going incredibly fast, it would take you about 3 days traveling here. So 250,000 miles away from our Earth. Now, 250,000 miles, some of you folks may have a car with that many miles on it. And if you can even imagine driving to the moon going 80 miles per hour, it would take you 4 months nonstop. Although I cannot recommend it. The roads are poorly maintained out here. And from here on out, folks, we're going to need to use a more useful measuring stick since at this scale, using miles is kind of like using inches to describe the distances between cities. Astronomers instead use a more convenient measurement known as light speed. Now, light travels at a mind-boggling speed of 187,000 miles per second. That's about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds to cross that distance at the speed of light. So that's kind of like a short pause in conversation. But folks, we still have a long ways to go. So now we're going to have to say bye-bye, moon. So everyone say bye-bye, moon. We'll see you later. And folks, now we're going to be taking a leap into a much greater realm of our solar system because now we're going to watch the moon and the Earth and its orbits as they slowly recede And on our journey, folks, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to the help of computer models like OpenSpace showing us the most accurate information and images available to us. So there goes our Earth. And now we're starting to see all the planetary orbits in our solar system. And now the nearest star to us, the sun, comes into view. Here comes the sun. Do, 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 do. And now we have a very nice bird's eye view of our solar system. Now, folks, the Earth is by far the biggest thing in our solar system, and the sun's about 93 million miles away from the Earth. 93 million miles, in terms of light speed, that's about 8.5 minutes at the speed of light from the Earth to the sun. Now, that's incredibly important because as the sun is shining sunlight, it takes 8.5 minutes to reach us, which is us over here. We're the third rock from the sun. So again, if the sun was to turn off all of a sudden, we wouldn't know about it here on Earth for about 8.5 minutes because it takes that long for that light to reach us. And then all of a sudden here on Earth, it would be nighttime. The further you travel into space, the longer it takes light to travel. You're kind of seeing that object as it was for that light to reach you. So we're kind of looking at the sun as it was 8.5 minutes in the past. If we're looking at a star that's 1 light year away, we're looking at that star as it was a year ago, because that's how long it took for that light to reach us. But again, since we have a nice bird's eye view, we're going to name the planets in our solar system real quick. So we have the sun in the middle. The closest planet to the sun is Mercury. Then we have Venus, Earth, that's us. And then we also have Mars. So these are the rocky terrestrial planets in our solar system. But there's also more beyond Mars. We have this nice little emptiness of space, but there's actually quite a lot of stuff there. Right there, we have our main asteroid belt, and this is what our asteroid belt would look like if we were to highlight all those asteroids. And then beyond the asteroid belt, we have the really big planets. We have the Jovians, we have the gas giants. We've got Jupiter, Saturn, Uranus, the funny one, and Neptune. And I can already hear a couple of folks, hey, Christian, you forgot about Pluto. I learned about Pluto in class. I love Pluto. Viva la Pluto. Well, folks, I can bring Pluto into our trajectory. So I'm going to be bringing up Pluto's trajectory on screen. Just appeared. That's a nice little blue line right here. Now, a lot of folks say, hey, Christian, what happened to Pluto? How come it got demoted from a planet to a dwarf planet? Well, you see, folks, in the mysterious year of 2006, we got really, really good at learning about our solar system. In fact, we got really good about learning at the outer part of our solar system, anything that's past the orbit of Neptune, in a region called the Kuiper Belt. And you're probably wondering to yourself, what's the Kuiper Belt? I've never heard of that before. Well, the Kuiper Belt is all this stuff. There we go. It takes a little time for OpenSpace to bring it up because there's just so many objects out here in our Kuiper Belt region. So pretty much you can think about the Kuiper Belt as a second asteroid belt. It's mostly icy asteroids, comets as well, and also quite a handful of dwarf planets just like Pluto. Now, because we found more than 400 objects out here, and we couldn't call all this stuff planets. There was just way too many of them. So all the astronomers, scientists came together in 2006, and they had a great big meeting. They had to figure out what exactly you need to be to consider a planet. So they came up with a whole new criteria in order to be a planet. One of the criteria in order to be a planet is that you need to be so massive, such a massive object that you kind of push everything else out of your orbital path. And unfortunately for Pluto, it does not push everything out of its path. It's kind of a small object, so it kind of does dances with different objects here and there, mostly with its moon Charon. So this is one of the reasons why Pluto got kicked out of the Planet Club, no longer considered a planet, but now considered a dwarf planet. But don't worry, folks. There's quite a few dwarf planets out here in the Kuiper Belt region. We have Make, Haumea, just to name a couple of them. So it's kind of like Pluto said, hey, you kicked me out of the Planet Club. I want to make my own club, the dwarf planets. But I want to put away the Kuiper Belt because that is a lot to look at. And before we leave our solar system, I do want to show you some of our space voyagers that we sent out to learn about our solar system back in the 1970s. We have Voyager 1, Voyager 2, Pioneer 10, and Pioneer 11. And it looks like it's taking it just a second for it to appear. There they are. So these orbital paths right here, these orange lines, these represent the trajectories of the different spacecrafts. We also have New Horizons, which did a quick flyby of Pluto. not too long ago. That's when we got our high definition images of Pluto, but we didn't do a full orbit around it, so we only got pretty much one side of Pluto. But we got a whole new look at Pluto. Now, all these spacecrafts are traveling fast enough to escape the sun's gravity, folks. But even the most distant of these robot adventurers has not traveled as far as light travels in a single day. Now, in order for light to reach the orbit of Pluto, that takes about light 10 hours at the speed of light. So, nowhere near close to a day. But we're going to be leaving the solar system because we still have a ways to go, folks. And now we're going to be traveling into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us over 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. And if my calculations are correct, Alpha Centauri system should be this bottom right star closest to us, right in the middle. So 4 years at the speed of light, that's about the same amount of time for a college education from freshman year to graduation, at least before the budget cuts. Hee hee hee. But folks, we're going to stop and consider whether humanity has made its presence known beyond our solar system, because now we're going to be heading inside something called the radiosphere. Whoa. So again, we are now inside the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting from the Earth. Now, this first began in the 1930s with strong radio waves, early television, and radar signal and later the detonation of atomic weapons. All these things are emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. Now, humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. Since all these signals are electromagnetic, they are traveling at the speed of light. So this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is always expanding at the rate of 1 light year per year. So is anybody out there listening? And folks, I'm going to be bringing up these markers. These markers represent some of the many thousands of stars astronomers have discovered over the last 22 years, which has one or more planet orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. And so far as today, 2021, we found more than 4,000 exoplanets in our nearby region to us. So we're constantly scanning the night sky, and we are finding exoplanets left and right. So that 4,000 count of exoplanets is going to rise steadily because we're constantly scanning the night sky, looking for exoplanets. Now, that begs the question, are any of these Earth-like? Well, our technology is not yet able to answer that question quite yet, but new generations of astronomical instruments are devoted for that search. But the more important point here is that quite a few of these planetary systems within that 90 light year limit of our radiosphere could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's able to listen in and answer back, the communication delays between hellos could be decades in time. For example, say we live in a star system on the one side of the radiosphere, on the left-hand side, and we find an alien civilization on the right-hand side. We spot them, we send them a hello message. It takes 90 years to reach them. They listen in, answer back, they say hello. Another 90 years. That is a 180-year conversation in the making. Whew, and I can barely wait for a text message from my friend. But folks, of course, planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. But folks, I'm going to put away these exoplanet markers, but I want to leave our radiosphere up there because that is a great reference point. As large as our human influence is on the universe, it is nowhere near as huge as our Milky Way galaxy. So keep your eye on that radiosphere, see if you can still see it, as we slowly pull away and look at our Milky Way galaxy. Can you see your house from here? Just kidding. But folks, again, we are now looking down at our Milky Way galaxy, and we have our radiosphere just right there in the far left of our galaxy. Now, our Milky Way galaxy is incredibly large, folks. If you wanted to cross from one side to the other of our Milky Way galaxy, well, that's going to take you 130,000 years at the speed of light. That is one very long road trip. But not only that, folks, our Milky Way is so huge, we estimate that there's at least 300 billion stars in our galaxy alone. If our recent discovery of so many exoplanets just within our small neighborhood within this vast star city is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave our Milky Way galaxy, I want to stress the shape of it. When we look at it from a sideways perspective, you notice that we live in a flat spiral disk of the Milky Way, kind of like a large pancake. Now, this is pretty important because when scientists and astronomers want to learn about the universe, it's so much easier for them to point their equipment galactically north and galactically south instead of looking through the plane of gas, planets, stars, debris that kind of obscures their view of the universe. So keep that in mind. We live in a nice flat spiral disk. That'll come important in just a little bit. But again, folks, the Milky Way is only one of many hundreds of billions of galaxies that comprise our known universe. Now, in this giant leap, we're now going to see a view where each point of light no longer represents a star, but now represents the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. And folks, we live in a local group of galaxies, which contains about 30 galaxies, large and small. This also includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door, and we're heading right for it. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. But as we continue zooming out, folks, you're going to start to notice that the universe is not evenly distributed through space. Instead, galaxies tend to clump together in clusters in great regions and voids, where some have very few galaxies and other regions have hundreds of galaxies. And now, folks, as we continue to zoom on out, this picture that we're now seeing represents the 30,000 closest galaxies to us in a space over 300 million light years across. And we have to give a special shout out to an amazing astronomer by the name of Dr. Brent Tolley, who worked at the University of Hawaii, who compiled this amazing galactic map for us. Thanks to the help of the workers of dozens of astronomers working over decades of time. They even color coded the densest regions of galaxies in yellow here. But we now have automated systems that are now mapping even the most distant galaxies. So now, folks, we're going to be looking at the large-scale structure of the universe. Wow. We just got a new update on our OpenSpace program, and these data points are very vibrant. I'm liking this. But this is the large-scale structure of the universe, folks. And again, every single point of light represents a location of an individual galaxy. Now, just a heads up, the universe is not shaped like a bow tie or a pasta noodle. These dark regions where we simply don't see anything right here, these are areas we simply haven't mapped out yet. Remember when I just told you that we live in a flat spiral disk of our Milky Way galaxy? Well, if we were to line up our Milky Way disk, it would line up just right there in that dark portion. This is where our disk plane is. So again, it's a lot easier for astronomers and scientists to look galactically north or galactically south instead of looking through all that gas and debris. Now, we wanted to make sure that there were still galaxies, even through that plane of gas and debris. We do have a small survey. We were able to find galaxies there, but again, incredibly difficult to look through all the debris in the way. But eventually, as our technology improves, these dark gaps will eventually be filled in. It's only a matter of time. But again, it looks like we're running drastically low on time, so we must continue pressing on out. And now, folks, as we continue zooming out, you're going to start to see all these orange dots. These orange dots no longer represent galaxies. They now represent very distant objects known as the quasars. Now, quasars are short for quasi-stellar radio sources, and these blazing objects are all billions of light years away. So now we're looking so far back in the depth of time and space to the most distant quasars that they represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So now we're going to press even much further beyond, before a time before quasars, before planets, stars, and even galaxies began to form. Folks, we are now stepping into the very edge of the known universe. And what we're going to be looking at is known as the cosmic microwave background image, or the CMB image for short. And here we are. So, folks, all evidence indicates that the universe that we live in is about 13.8 billion years old, and this is data compiled by Planck and other radio telescopes. Now, this is a picture of the very baby universe, only 380,000 years after the Big Bang occurred, where space and time began. But what we're looking at is not a typical photo, but a temperature density image, where the light echoes of the Big Bang are color-coded with the light areas corresponding to the hottest, least dense regions, and the darker areas are the coolest, densest regions. Now, these fluctuations in temperature and density are extremely, extremely tiny. They vary no more than 1 part per 100,000. But eventually, that very minute differences, those small differences, gave rise to that large-scale structure of the universe that we saw earlier ago, that clumping and clustering of galaxies everywhere. Figuring out just how this happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we've now traveled as far back as the law of physics can physically allow us, so we only have one direction left to go, back home. Now, before we make our trip back to planet Earth, I've got to ask y'all to prepare yourself, because this could possibly be the worst free-falling dream ever. But let's find a nice entry point through all these data points, through all the quasars and galaxies, and let's begin our trip back home. So, folks, we're going to be crossing an expanse about 13 billion light years. Now, we present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. Now, we live in a golden age of astronomy with new generations of telescopes and spacecrafts extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. Now, with that thought, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders that our universe has to offer. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you again to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, folks, and I do hope you'll join us, those who dream amongst the stars. But we just entered our Milky Way galaxy. We're about to enter our radiosphere. We're making our way downtown, walking fast, faces past when we're homebound. And of course, we are entering our star system, seeing the true brightness of our sun from the outside, passing those space voyagers we sent out in the 1970s to explore our solar system, passing that Kuiper belt, and making our way to the third rock from the sun, our homeworld, the only place humans have occupied in the vastness of the universe, the place we call home, planet Earth. And folks, as we make our final approach to planet Earth, this is going to be the end of our Tour of the Universe show. I want to thank you all for stopping by and watching it with me today. I hope you did enjoy it. But again, it looks like we made it back home to planet Earth safe and sound. And that's all I have for you today, folks. Thank you for stopping by. Have a wonderful day.